The engineer of this train can see perhaps up to a mile ahead on this straight section of track. If a stalled vehicle or debris is suddenly seen at an upcoming grade crossing, such as this one, there's little chance the train can stop in time. It's a simple fact. Trains need more room to stop than the distance an engineer can see down track. Keeping our railroad service running safely and smoothly requires constant attention and careful planning. The current system has served us well, but the rapid-paced demands of the 90s will require our public transportation infrastructure to perform even faster and more efficiently without compromising safety. The development of high-speed rail links is already underway. New York State, for example, has established a high-speed service linking Albany to Buffalo with trains routinely running at speeds in excess of 100 miles an hour. The New York plan calls for these speeds to increase to 125 miles per hour by 1999. Currently, trains on this line pass through more than 100 grade crossings. As trains and rails are upgraded to handle these faster speeds, safety, specifically at grade crossings, becomes an even more urgent concern. One solution to this concern would be to build overpasses to replace grade crossings. But at $5 to $30 million each, the cost would be prohibitive. A more viable option was proposed by New York State's Rail Safety Engineering, suggesting that each train be equipped with a video display monitor, acting as sort of a crystal ball, which could see 3 or 4 miles down the track. That crystal ball, in fact, has already been developed. Wireless Technology Incorporated, in conjunction with the New York State DOT, has made U.S. railroad history by successfully recording the first wireless video link between a high-speed train and an upcoming grade crossing. For the first time ever, traffic conditions at the Lincoln Avenue crossing on Conrail's Chicago line, Albany Division, were observed continuously by an approaching Amtrak train beginning more than 4 miles up track. A Wireless Technology directional video transmit antenna was mounted at the crossing, pointing the camera signal down the track toward the eastbound Storm King RTL turbo train, which had been fitted with a special onboard video receiver. The actual results are seen here, as recorded on videotape aboard the Storm King, which is traveling at 96 miles an hour when it locks into the grade crossing video signal. At 4:44 on the tape, the train is 4.2 miles down track. Then at 5:21 on the tape, the train's speed has increased to 100 miles per hour, and we see cars entering the camera's view at the Lincoln Avenue crossing. The small square changing color and the surrounding graphics is the Autoscope vehicle detection system from Econolite Control Products. This computerized traffic detection system is installed at the crossing and transmitted along with the camera's signal. This can tell the engineer the name of the upcoming grade crossing and other pertinent information. At 5:47 on the tape, the train is 3 miles out and the video signal remains steady and clear as we see the last car cross the tracks before the barriers come down. At this distance, the train could still be stopped safely if the crossing were blocked. As the train reaches Lincoln Avenue, we can actually see it for a brief moment as it passes through and out of the directional transmit signal. This wireless video link between a high-speed train and distant grade crossing will enable engineers to evaluate the safety of each crossing early enough to react accordingly.